Hello, welcome to my tutorial on fault tree analysis. My name is Steve McWilliams, and I'll be your guide through this course. The target audience for this course are instructional design, development, and evaluation students. The objectives of this course are to provide background and develop an understanding of the fault tree analysis tool, to explain the context of the tool's use, to elaborate on the tool's application, to discuss the elements and procedures within the process, and to discuss the advantages and disadvantages of the tool. Following this tutorial, learners will take a 10-question quiz or check on learning. The quiz is linked below this video. Let's get started. So, what is fault tree analysis? In general, fault tree analysis is an analytical technique with a top-down approach that examines the system, surfacing probable causes of failure within the system, specifically noting the cause and relationship within the larger system. Thus, this tool as a lens improves the likelihood of success within the project or system. But wait, there's more. This analysis is a graphical tool that illustrates the system, its connections, and enables exploration in identifying potential system failures and causes through Boolean logic and Bayesian probabilities. Boolean logic helps in analyzing the complex system simplification rules, while Bayesian probability focuses on the belief or confidence in a proposition in terms of percentages. Ultimately, this representation and analysis enables the development of interventions that stem potential failures. Developed in 1961 by Bell Laboratories, fault tree analysis led to the success of the Minuteman missile launch system, and later, with refinement, the technique was leveraged by Boeing in quantifying the probability of events. In recent use, fault tree analysis assists in examining complex events, such as those using computer-controlled equipment. The tool, primarily used in hazardous industries, evolved to a much wider application. Fault tree analysis connects the evolution of conditions-based maintenance, enabling preemptive measures in scheduling and repair. Let's look at a more general technique or application related to fault tree analysis, termed failure analysis. Failure analysis uses the same techniques in achieving the same goal or end state, with a wider application, ultimately connecting to successful project completion. Modern-day firms use a form of failure analysis in recognizing potential areas prone to failure while identifying a need for training to overcome obstacles that may arise or impact the ultimate success of the project. Fault tree analysis connects to more fields to include social service systems. With a wider application, one thing that we see in common is risk identification and mitigation strategies surfaced with this analysis tool. Let's briefly discuss the symbology associated with this analysis tool. While not an all-inclusive list of symbology, as many variations exist, the common symbols associated with the 4 types of fault tree analysis events are located on the left. A circle denotes a failure that cannot be developed any further. A rectangle represents an event resulting from a combination of fault events that do require further development. A diamond represents an event that cannot be developed further due to a lack of information, unlikely probability, or affordance in examining this event. In this situation, diamonds equate to basic events. The house represents the normal occurrence of an event, and by itself would not produce a failure event. Looking to the right, these two symbols serve as gates. One denotes and the other or accordingly. Please take a moment to review this fault tree analysis. This example illustrates a simplified portion of the fault tree analysis associated with the Minuteman missile program. In this scenario, this analysis focuses on a computer-controlled component within the larger system. Take a moment to review this fault tree analysis. This example centers on insufficient sales within a business region over the course of 10 months. Note the contributing factor connected to the human component and market competition. In this analysis, it's easy to see that factors contributing to a failure within the system are essentially poor employee relations and turnover linked to a lack of communication, inflation, and a lack of increased pay. Additionally, the uncontrollable element of market competition and decisions to not proceed with new model releases impact the market, thus impacting sales. We will now discuss the key steps involved in conducting or developing a fault tree analysis. Essentially, we're running through the procedures. In the first step, we define the system, identifying purpose, mission, and goals, while delineating boundaries and noting constraints of the system. We analyze the mission with the intent of breaking mission goals into smaller units. We identify the undesired events using a group of experts. We then rank the undesired events, determining which needs to be addressed first, factoring the probability and/or severity of the event. We determine the level of each undesired event, specifically and whether the failure is at mission, function, or task level. We then identify failures contributing to the undesired event through thorough analysis, developing each event until the event cannot process or develop any further. We specify the logic gates between contributing events. In this step, users determine the combination of events that equate to failure by looking at the relationship between the events. We develop the tree to the next lowest level until finished. Each level requires development before proceeding to the next lower tier within the analysis diagram. Remember, this is a top-down approach. Once the fault tree diagram is complete, the tree is further validated, confirming its accuracy. The tree is then labeled in hierarchy from top to bottom, beginning with the sequence of A through the necessary combination of letters and completing the tree. As necessary, users then conduct quantitative evaluation from the top down, determining the probability of failure for each event, while considering the frequency or likelihood of a failure event. Each event is then further classified to determine the possibility of correction or remediation. A quantitative evaluation is not necessary for smaller fault trees, given the ability to visually assess the data. However, large trees typically enlist computer programming and calculation. Upon completion, the representation and data provide critical paths, sequences of action or activity that indicate causes of failure within the system, and in this aspect, remediation measures can be incorporated to avoid these problems or mitigate risk accordingly. Let's look at the advantages of fault tree analysis. It enables expert judgment, with focus gathered from different disciplines. It accounts for events, connections, and inputs, focusing on priority, probability, and severity. It focuses on the system operation, not the personnel. So, it's not threatening. It provides a graphic representation that lends to understanding and communication while noting other causes of failure. And it highlights job and goal components that need training. With such a thorough and analytical technique, can you imagine the disadvantages? Well, it's time-consuming. It uses a complex methodology. It requires a level of subjectivity, leading to potential inaccuracies. And the size of the overall system may require complex work and specialized computer software. Over the course of this short tutorial, we covered the background and developed an understanding of the fault tree analysis tool. We covered the context of the tool's use while elaborating on its application. We discussed elements and procedures within the tool, and then covered advantages and disadvantages. Listed below are the references used in constructing this tutorial. Thank you for taking the time to engage in this tutorial. Please proceed to the link below this video and assess your knowledge through a check on learning.